Hi everybody, this video is on how to find the inverse of a matrix by hand and then how to use that to solve a system of two variables by hand, and that will be your fifth way because so far we know graphing, substitution, elimination, Cramer's rule, and then inverse of a matrix by hand. Now we already did inverse of a matrix on a calculator, but you're going to learn how to do without a graphing calculator now. So two key things for this video are inverses and identities. So I want you to write down this here as a reminder. The stuff you already know about inverses are that there is a multiplicative inverse, and with just general numbers, a multiplicative inverse is the number we multiply by to get the multiplicative identity. And the multiplicative identity is 1. So for example, if I take 4 and I multiply it by its multiplicative inverse, I'll get the multiplicative identity. Similarly, there is an additive inverse, but this time it's the number, whoops, hold on. I had a typo there, make sure you fix that. It's the number we add to get the additive identity. And the additive identity is 0. So for example, if I take 4 and I add to it its additive inverse, I'm going to get the additive identity, which is 0. So with matrices, there is also an identity matrix and obviously inverse matrices. So before I tell you anything about those, I want you to pause the video and multiply these 3 sets of matrices by hand. You can just do it in your head and write down the product for each. So make sure you pause the video and do that on your own. Check your work here. You should have gotten these 3 matrices. And you should have noticed that for the first one, when I multiplied by this matrix, this is actually a diagonal matrix, you get the same exact thing. It hasn't changed. And whenever you multiply these 2 sets of matrices with one another, you get this diagonal matrix of just 1s. Now, this matrix here, this diagonal matrix just of 1s, this is the identity matrix. And it's going to be very important for what we do today. And that means that these 2 matrices, then, if you multiply them and get the identity, that means these must be inverses. So I multiply 2 inverses and I get the identity, just like here when I multiply 2 inverses and I get the identity. So this matrix here is the equivalent of multiplying by 1. It doesn't do anything to it. Just like when you multiply a number by 1, it stays the same. If you multiply a matrix by essentially 1, it stays the same. Now you have not just 2 by 2 identity matrices, you can also have the 3 by 3 identity matrix, which is still just a diagonal matrix with elements of just 1, and it's obviously going to be square. Now, if we can only have a square identity matrix, that means you can only find the inverse of a matrix if you have a square matrix. So that is key here. You can only find inverses for a square, like a 2 by 2, for example, matrix. Now, you could do this on a graphing calculator. We already have done it. We're going to just do 2 by 2 inverses by hand. We're not going to go any higher than that. You obviously could. You can just Google it and see the steps. It's a little bit intense and a little bit beyond what we need to do. So here, you might notice something about the relationship between a matrix and its inverse matrix. They look somewhat similar. There are slight differences. This is the actual step for how you're going to get the inverse of a 2 by 2 matrix. Let's say you start with A, B, C, and D. What you need to do first is get the determinant of A. You're going to do 1 divided by the determinant of A. That means that the determinant of A can't be 0 then, because you can't divide by 0. And what you do is you take A and D and you switch their locations in the matrix. And then you take C and B and make them the opposite sign, and you multiply each element here by 1 over the determinant. So you're multiplying each element basically by a fraction, and that gives you the inverse matrix. So let me do a couple with you here, and then I'll have you try one. So I want the inverse of this right here. So I have A, B, C, and D. So I'm going to start by finding the determinant of A, and the determinant of A, that would be, let's see, negative 15 minus negative 16, and when you add them you get 1. Whenever the determinant is 1, it's a lot easier to get the inverse matrix, and you'll see why in a second. 1 over the determinant of A, this goes here. So you're basically just multiplying your switched matrix by 1, so you don't have to worry about fractions, which makes it a lot nicer. You'll see the difference whenever we do example 2. So I'm going to take A and D and switch their locations. So negative 3 and 5 has switched spots. I'm going to take 8 and negative 2, and they're going to stay where they are, but they're going to become opposite signs. So if I multiply this by 1, it's not going to change. And I end up with this as my inverse matrix. Now I want to try one where the determinant is not 1, so it's going to be a little bit more work here. Not too bad, but just some fractions. If I get the determinant, I'm going to do 24 minus 2, which is 22. And the inverse is going to be now 1 over 22 times my switched matrix. So I'm going to switch the locations of 6 and 4, my A and D terms. And B and C are going to stay where they are, but change signs. And then I'm just going to multiply each of these by 1 over 22. So I have 4 over 22, negative 1 over 22, negative 2 over 22, and 6 over 22. And then you could obviously reduce all of these, which we're going to want to do because whenever you multiply, whenever we go to solving a system, it's easier if you have smaller numbers and reduce fractions. All right, so I'm going to have you try this one here. Now, make sure you actually try it. Some of you like to skip the you tries. It's good practice. And I will show you the answer in class. So write this one down, pause the video, and find the inverse of this matrix right here. And again, in class, when I see you again, we'll compare answers. Now we want to see how we can use the inverse matrix to actually solve some things. So we're going to start with a matrix equation set up like this, and then we'll move on to systems. So let's say I have a matrix multiplied by some mystery matrix, and I end up with this matrix. I want to know what did I multiply this by to get this. So I'm looking for matrix X. So I have a 2 by 2, and I end up with a 2 by 2. So you want to think, all right, it helps if you know what dimensions you're looking for. If I multiply 2 by 2 by a 2 by 2, I'll end up with a 2 by 2. The inners are the same. The outers give you the final dimensions. So I'm looking at a 2 by 2 matrix. So what we're going to do is think, how am I even going to get my X matrix alone? If I call this A and I call this B, let's go over here. I right now have AX equals B, and I want to get X alone. Now, if these were numbers, we would just divide by A, but remember, you can't divide matrices, so this should be familiar because you've already done this before. If I multiply by the inverse, and it has to be on the left, remember, order matters, A inverse times A. You want to think, what happens there? If I multiply a matrix and its inverse, which we did here, you end up with the identity matrix. And the identity matrix is basically the equivalent of 1, and multiplying by 1 does nothing. So A inverse times B. I is the identity matrix. And the identity matrix times X is just X, because multiplying by I does nothing. It's like multiplying by 1. So we're going to need the inverse of A in order to do this. So let's start by finding the inverse of A. A inverse is going to be 1 over, so I need the determinant of A. The determinant of A is going to be 8 minus 7, which is 1. So I have an easy determinant here. So my inverse is 1 over 1 times, so I'm going to switch 2 and 4. So 4 is here now, 2 is here. I'll switch the signs of negative 1 and negative 7, and multiplying by 1 over 1. I get this. So let's go ahead and take our original, which is here. And we're not going to write out all these steps every time, just this time, so you can see what really is happening. I'm going to take and multiply by this on each side. So I have 4, 7, 1, and 2. 4, 7, 1, and 2. So I'm multiplying each side by the inverse on the left. And these two right here, remember, this is A inverse, this is A, this is X. This is A inverse, this is B. And when I multiply A inverse by A, these are going to cancel, giving me the identity, leaving me with just X. So now what I have to do is multiply A inverse times B. And when I multiply those, I end up with negative 84 plus 84 is 0. And then I have 12 minus 14 is negative 2. And then I have negative 21 plus 24 is 3. And I have 3 minus 4, which is negative 1. So there's your mystery X matrix. You can also solve a complete system of equations. So this was just a matrix equation setup. We're looking for a mystery matrix X, and it was a 2 by 2. You can also solve a system of linear equations, and we did this on the calculator, and we're going to do it by hand now. So this is where we had our coefficient matrix, our variable matrix, and our constant matrix. And this is just like what we did above, except we're not going to end up with a 2 by 2. We're going to end up with a 2 by 1 because x and y are set up in such a way that it's 2 by 1. So our mystery matrix xy is just smaller, and it's the same process. So I'm going to multiply each side by A inverse on the left, which will then cancel these and leave xy alone. All right, so let's start with the determinant of A. So that would be -2 minus 15, which is -17. And then what we're going to do is get the inverse of A. So it would be 1 over -17 times, switch the location of A and D, switch the signs of B and C. As you can see, we're going to have some semi-ugly fractions here. I'm going to multiply by 1/17 to each term. So some of them become positive now, and that first one was negative. All right, so we're going to multiply A inverse on this side, which cancels, and multiply by A inverse on this side. So this is exactly what you did on the graphing calculator whenever you typed in A inverse B on the main screen. So here's A inverse, -1/17, 3/17, 5/17, and 2/17. So there's my A inverse, and here is my B. But instead of typing it in the calculator, we're going to do it by hand. So fraction time. Let's see, I have -1/17 times 11. That's 11/17 plus 3/17 times 19. That's 57/17. And then that would be 68/17, which ends up actually being a nice number, 4. So that's my x. And then I have this times this, -55/17 plus this times this, 9 times 2 is 38/17. And when you add -55 and 38, you get -17/17, which is -1, which is your y. So here's your ordered pair, 4, -1. So the size of fractions is not too bad as long as you remember which elements to switch and which to change the signs for. So I'm going to give you one you tried to do, and we'll check in class. Follow the exact same process. You're going to do A inverse times B. So start by finding the determinant, then the inverse of A, multiply it by B, do the fraction work by hand. It's good practice. So do that one, and we will compare in class. Bye.